Hello viewers, today we would be continuing with the part 3 of chapter electricity. So in the last video I've told you what is a resistance, and in order to show you a clear picture of what exactly the resistance is, I'm going to show you this thing. See how clearly it is given. Let me just make some changes here. Okay, so if you have a look, what happens electrons, and when the electrons are being pushed away, we know because of the wire, the current or the electrons won't be allowed to move easily. So this is a cartoon of showing all the three things: voltage, ampere and ohm, but that is basically the resistance. Okay, now continuing with what is now Ohm's law. Okay, so if suppose we have a resistance symbol is given by this, and resistance is the opposition to the flow of current, and resistance you can take anything, like it could be a fan or it could be a bulb. I mean anything that consumes electricity is a resistance, right? And you connect it to a, say this is a battery. We know the current will flow from positive to negative. This is positive, this is negative, so by conventional direction it should be positive to negative. And one thing you have to remember is that if you increase your voltage, suppose this is say 5 volt battery, right? So current generated would be according to 5 volt. If you increase it to say 10 volt, so it will generate more current. So the law states that the potential that you use, potential difference, is directly proportional to the current. And if you want to remove this proportionality sign, you have to put a constant. So let that constant be say R, and this is I here is resistance, right? This is resistance, and more the voltage, more would be the current generated. Along with that, if you just keep this R here, so my value of R will become this, and V by I. So this V is volt and I is ampere. So the unit becomes volt per ampere, which is said to be ohms, right? Already told you ohm is the SI unit of resistance. Now next, when we come to the resistance, we should know one more term that is said to be the conductance, right? What is conductance? Conductance is basically the reciprocal of resistance. Resistance is given by symbol R, so conductance would be reciprocal of this 1 by C. What was resistance? Resistance was opposition to the flow of current, right? And conductance is, you can say, the how easily the electrons can move during current. So that is said to be conductance. So just the opposite of that. And if you plot a graph V versus I, you will get a straight line, right? For suppose here I've taken two conductors, say A and B. This is a very common question in board exam, and you must have seen the previous year specimen papers or board papers. You must have seen this kind of question where they give you the graph and they ask you which one has got more resistance and why. Okay, before I tell you anything, just remember, if you have V versus I graph, so the straight line, this actually shows the resistance, right? This is the resistance. Slope of the line is going to give me the resistance, and I hope all of us know how to find the slope. I'll just write down the formula: y2 minus y1 upon x2 minus x1. This is how you find the slope. And in order to find slope, when you'll find the slope, you'll get the value of resistance. Okay, now suppose you've got two lines here and they ask you which one has got more resistance and why. So remember, higher the slope, steeper the line, more is the value of slope. Like you can just imagine to be a mountain. I'll just say, if I draw a mountain, a rough mountain, so here you will find it more difficult to climb up compared to this. So it has got more slope. So more the slope, more is the value of resistance. So you will say A has got more resistance compared to B, right? So this is very, very important. Okay, now along with that, if suppose they don't ask you resistance, but they ask you which one has got more conductance. So remember, conductance is inversely proportional to resistance, right? So here if A has got more slope, right, A has got more resistance compared to B, so just the opposite of that, that would be B will have more conductance compared to A. So this you have to remember, very very careful. And yes, it's not like you are going to get this graph like V on y axis and I on x axis, it could be something else also. Let us see how. So if suppose they give you graph say in this way, here they give you say V, here they give you I, and now they plot, and now they ask you which one has got more resistance. So make sure, don't just blindly write that, you know, I, because here it has got more slope, so yes, A will have more. No, it's actually the line which is more close to V, right? Remember, the line which would be more close to V is having more resistance. So if you see here also, when I explained you here, so here also this line A was more close to B, right? I'm not going to go into detail that slope of, you know, if you take graph like this, it is going to come out to be more. I'm not going to take that, right? Just for your understanding, and in exam you have to, you know, use the theory as fast as possible to come to the conclusion part. So just remember, the line which would be more close to V will have more resistance, right? So you just have to see where is your V drawn. Is it on y axis or x axis? Whichever line would be closer to V, that is voltage, you will write the more value of resistance. Okay, so here if suppose I ask you, this is given to you, I have seen one of the questions or not exactly like this, but yes, kind of this, lines are not correct, right? Please pardon me for that. Just I'm going to write here this thing A B C D. Now if suppose they there was an MCQ question and it was asked that which one of them is the correct order given, right? And there were 4 options given. So if you are clear with that, so we are very much sure that resistance for, yes, D is close to V, so you'll write resistance of D is greater than resistance of C, greater than resistance of B, greater than resistance of A. You find this out, you'll find this kind of question in this year specimen paper as well, right? So remember. Now after that, if suppose I ask you the same question, but if I ask you which is the correct order of conductance. So conductance is just the reciprocal. So if this has got more resistance means more opposition. Current would be stopped. So if current is stopped, conduction won't be done, because conduction is how easily the electrons can flow. So if resistance is more, opposition is more, conduction would be less. As a result, what will happen? Yes, our A will have the maximum conductance because resistance is least, followed by B, C and D. So conductance for A would be maximum, right? Now before we end up with this topic, you make sure one thing here, that this Ohm's law is only and only valid if you have a constant temperature. This is very very important. And yes, when you write the statement in your exam, please write the exact statement. Don't try to frame it in your own word, because this is a law. Of course, law cannot be changed, so better to write it in your own words if you don't want any kind of deduction in your written part. And yes, remember, temperature should be constant, because you should know one thing, as the temperature changes, resistance will also change, right? We are going to discuss the next part as a factor, so will be clear with why this happens, and I'll give you one example also to explain you, right? Now the next part, limitation, I told you only temperature is constant, right? Now let me just discuss about the factors. Factors are very very important, right? So let us come to the factors, which would be the last part for this video. So first factor that affects the resistance is your nature, right? Nature of wire means what kind of wire you are taking. Are you taking a copper wire, or are you taking a wire which is a not so very good conductor of electricity, or it is a very good conductor of electricity? For example, if you take silver and if you take copper, all of us know that silver is a better conductor, but because it's very costly, so we don't use this as a wires at our homes or at the places, we preferably use copper. And suppose if they ask you, say they give you lead and they ask you, out of lead and copper which is a better one, so you'll say because copper. So remember, why copper? Because copper has got more free electrons, compared to lead, right? And yes, the resistance offered by this particular material is less. Resistance is less means opposition offered by the wire is less, and if the opposition is less, what will happen? Ultimately your the conductor would be a better conductor. Wow, conductor would be conductor. Okay, I mean to say that it would conduct electricity in a better way compared to the other material, right? So first thing. Second is the length of the conductor. Okay, so length of the conductor, as I discussed in my previous video, that resistance is the opposition to the flow of current, and more the number of collisions, more would be the resistance. Okay, if you suppose increase your length of the conductor, suppose if you take this much as a length and this much as a length, right? Yeah, so because here the length is more, so the chances of the collision among the electrons and with the wires would increase compared to this particular length of wire. So it means more the resistance, more is the, or sorry, more is the length, more is the resistance of the wire. And second is the thickness, not second, sorry, third is the thickness of the wire. Thickness, if you increase the thickness means basically the area that you are taking into account. So if electrons have more space to move in this particular wire, so we know that it would undergo less number of collision with the walls of the wire, and yes, the electricity conducted would be more in this particular wire, right? So more the area, less is the resistance. Here what was the factor? More the length, more is the resistance. So they are here directly proportional, here inversely, right? And the last is the temperature. Now in order to understand temperature, I told you before already in the previous one, Ohm's law, that the temperature should be kept constant, right? So if suppose if I give you an example of summers and winter, when you charge your phone, mobile phones, you must have seen in summers your charger gets hot very fast, and when the charger gets hot, what happens? Your electricity flow decreases and the charging is reduced, right? If you're not observe it, do observe it, right? And as the winter approaches, you have seen it yourself that charging occurs faster. So what does it mean? As you increase the temperature of the surroundings or of the wire, what will happen? The resistance will also increase. For the conductor, the resistance will increase, and when the resistance will increase, what will happen? Ultimately the amount of current flowing in that wire will decrease. So you can relate this particular thing with your charging. You'll remember it for your whole year, or maybe through your whole life. Maybe I'm not sure about it, but yes, for now you can remember that. Yes, and now one more thing. If you increase the temperature, right, for example in summers, as I said, so surrounding temperature is also more, right? Along with that, what will happen? The electrons will have high kinetic energy, right? When you must have done it, that kinetic energy and temperature, they are directly proportional, right? So I'm explaining this thing in terms of physics now, that if temperature is more, kinetic energy of electrons would be higher, and when they have higher energy, they will collide with each other, right, with a very high value, with a very high energy, and yes, the collision will give rise to more friction, and yes, it will result in resistance. I hope that thing is clear to you. And when you decrease the temperature, and the opposite thing will happen, kinetic energy will decrease, they won't collide with much force, and yes, what will happen? The friction will reduce, and ultimately the resistance will decrease. And इससे we come to know one thing, that resistance and current, they are inversely proportional. Yes, of course, we know that already. We did V is equal to IR, if you remember. So here if you shift R here and I write it, so I know they are inversely proportional. Means if your resistance is more, current would be less. Opposition is more, electrons will find difficult to move in, they are not able to move freely, what will happen? Your current will decrease, right? So I hope that you have understood whatever we have discussed, and after the factors we would be coming to, you know, the other parts, that is resistivity and the conductivity part in the next video, right? So hope to see you all there. Thank you so much.